Leading off today's talk will be Yousef Khalidi. Yousef is Corporate VP, Azure for Operators, a new organization at Microsoft. Prior to this new role, Yousef was CVP of Product Management for Azure Networking. Given that this new Azure for Operators group was formed just 2 months ago, I know I'm looking forward to hearing from Yousef and getting an update on Microsoft's activities in this exciting space. So with that, Yousef, please take it away.
Thank you, everybody. Good morning and good evening, wherever you might be. And thank you for giving me the opportunity to speak to you. Today, I'll be discussing with you some of the movement we're seeing in the industry around 5G and computation at the edge. So I want to start first with our, if you will, our Microsoft 5G Edge vision. And this will look hopefully familiar to many of you. Honestly, it's all about intersection of the virtual and the physical world. In the past, maybe in the generation of 4G and before, it was all about communication, connectivity perhaps, which is great, but there's now more that can be done. By combining connectivity and computation with almost real-time connectivity, also what options are possible. For example, in the past, you may get data from your devices, from your connected devices, whatever the case may be, push them into a data store somewhere and maybe reason about them in batch, in slow time, eventually figure out what's going on. Now we have the opportunity to close the loop, to truly do real-time action on machine learning and AI on all this data you're getting here. Now, of course, laws of physics have to be obeyed. So you need to compute close to what data is. So what we see basically now, there's a true potential to intersect this virtual notion of where things might be, where things should be, managed and the like, with the actual physical world, the actual devices, the actual connected entities, if you will. This would require, as I mentioned, pushing computation closer to the edge. But as you would see in a second as well, toward the end of this talk, some things also will be pushed out from the edge, from on-premises up to the cloud as well. So there's a movement in both directions, to be frank. Okay. Now, all of us have seen a slide like this one. It's actually happening finally, where our edge applications are truly being deployed now across many industries out there. We speak a lot of maybe Industry 4.0, connected enterprises, but it's happening across the spectrum from, on the floor manufacturing scenarios, transportation, retail, healthcare, you name it. So I'm going to give you 3 specific examples in which we deploy technologies with partners. And after those 3 examples, I'm going to discuss some of the technology underlying these examples. Okay. So for example, we have been working with a company called Atobatix for warehouse automation. This provides, when you have a local private network in this case, you can really end up with ability to control these machines. These are small robots, basically, that can work in a very confined space, very precisely. So the network itself is 5G or even private LTE with the right properties here, but with computation right there on the retail, or in this case, the warehouse floor. The loop is closed between the devices and the computation. Data is being pushed out to the cloud for analytics, not real time, if you will, because the real time stuff is being done on premises. And the whole solution actually is up and running with, frankly, a small box with a local radio in the local floor, warehouse floor. This is a real example. It's happening as we speak. If you try to do this thing with Wi-Fi, good luck. It's not going to work, really. It's not going to be, the location information will not be correct. And the security model with Wi-Fi is problematic at best, if you will. Another example is work we've done with Tactile. This is a mixed reality example where you can provide real-time instructions to workers on the factory floor or on the customer premises through guided tasks, feedback, and we use a notion of digital twins from the IoT stack to improve the learning and the connection between the virtual world and the physical world as well. And again, physics are important here. So unless you're computing close to where the worker is or where the environment is, you can't really get the job done. At the same time, you do need the power of the cloud behind this whole thing, both to get you more data from the cloud and to store information back to the cloud so you can do a job next time better if you want. And again, these are real examples. A third example is work we've done with Everseen. This is a real-time workplace safety and productivity solution where you can look at a scene, in this case in the gas station, and you find people, things, and take action to improve safety. So for example, if you see someone light a cigarette in the gas station, it actually happens, you can take some action on this, real time, etc. Now, again, the computation has to be local. You want accurate communication as well in the local network and connectivity up to the cloud for other processing after the fact, if you want. Okay, these are actually real examples. We have many of those. We can look at them, but let's talk more about now what underlies these kind of examples. In a nutshell, you need a whole spectrum of computation to make this happen. From the big mega clouds, and Azure is a big one, Amazon's a big one, of course, there's Google as well. You have these big mega data centers around the globe. There you have a suite of services, very rich suite of services. You want to store petabytes of data is easy, etc. But the question really is how to push the right computation in the right location on that spectrum. So moving from left to right on the slide, you have the big regions, you have edge zones, which are closer on the edge of the network. So you're closer to your customers, if you will, to edge zones that live with the carriers, with the operators. So you can truly integrate this with your network infrastructure. So you're basically one hop away from your 5G infrastructure. All the way to on-premises, on the customer location, on the factory floor, the example I gave earlier, of essentially a combined computation and network infrastructure through Azure Private Edge Zones. And the beauty of this model, by the way, is the programming models across the spectrum is very uniform. Typically, it's container-based. You can do also on VMs here. The manageability of this spectrum is controlled from the cloud. You can run in disconnected operation, of course, but you get a lot of power of computing, managing from the cloud, and you place the right computation where it should be. Now, double-clicking a bit more, we have the notion of Azure for Operators, which is a way for operators to consume, if you will, to provide services to their customers as well. Few principles I'm going to go through in the next slide in a second, but it's all about your customer, your service, powered by all this infrastructure. Frankly, I'll speak for Azure. We have no interest of becoming an operator or a carrier. We have no idea how the stuff really works, and as far as dealing with big radio networks and dealing with customers and so forth. However, we understand computation. We understand networking and how we can combine these two together. I know it's a busy slide, but the point of it is that there's a bunch of services here which are available to be consumed, that can be consumed, as I mentioned, across the spectrum from the public cloud all the way to the edge. And very importantly, there's a partner ecosystem that goes with this. No one company can do this by themselves. Partners are extremely important, including the operators, of course, themselves and the ecosystem for operators. And you know the list very well, NFVI partners, OSS, BSS, and so forth. When we started this work, by the way, we really wanted to have very key principles here on how we will be working with operators and carriers. And I'm not going to drain this whole slide, except to tell you that it's very much a partner-centric approach. As I mentioned earlier, we understand the cloud very well. We've been in this business for a long time. Here, we need to, if you will, marry the technologies on the cloud with operators and carriers and to meet their needs. So it's all about bringing the power of the cloud to the operators. It's about a partnership model. We are a platform business. We're a bunch of plumbers, if you will. So we're going to work on the infrastructure, making a carrier-grade cloud, enabling the industry, the ecosystem to benefit from the infrastructure. As we did in the basic cloud model, we will meet operators where they are today, on premises, at the edge, or in the cloud. We are not saying you have to move to the public cloud wholesale. Actually, it's not going to be the case because of physics, as I mentioned earlier. At the same time, workloads can move. Some workloads can move to the cloud, and others will have to be pushed to the edge as well. And we're going to support the complete ecosystem. I'll give you examples in a second. And we know it's going to be a journey. When the cloud started many, many years ago, many enterprises took the time before they moved to the cloud because they needed to know what the cloud is, and the cloud had to become more mature for them. The same thing will happen here. Example of partners. This is the partners here's a sample of the partners we have today for the Mac, for the on-premises solutions. This is not a complete list, by the way. And some of our partners may not be on the slide, apologies. The point though is you need to get the ecosystem with you. We need to get the ecosystem with us to serve your needs better. So, and you know how this goes. You need to have the device partners, the RAN, the actual EPCs, etc., along with the ability to put solutions together. So managed service providers, integrators, and the operators themselves are really needed to get an end-to-end solution for the end-to-end customer. Okay. I want to talk about two specific scenarios we're seeing a lot of traction in the marketplace today. And then I'm going to show you, I'm going to conclude very quickly after that. One scenario we're seeing today is very much as private networks with a standalone model. This is when you drop basically a box. In this case, if you look at the very bottom of the slide, the Azure Private Edge, that contains a complete mobile core plus ability to compute on premises in the same box, if you will. This is where the examples I gave you earlier, all of them, by the way, is very much fit this model, where the local network is ran from the local network in the location, the factory, in the gas station, etc. Is completely run from the same box. A lot of computational power is available on the box through container-based solutions managed from the cloud. And by the way, when I say private network, this can be either using the spectrum from the operator, managed by the operator, or in some markets, it could be maybe open spectrum like CBRS or unlicensed and so forth. So for us, when I say private cloud, it's not something that the operator is not using. As a matter of fact, many of our customers prefer to go through an operator because they want someone who really understands radio, who really understands how to service their needs. So this standalone model, a lot of traction out there. Another model we're seeing is the carrier edge extension model, where the carrier will continue to run their mobile core, the real core, the consumer core, the IoT core, and their infrastructure on their edges, on premises, and so forth. But they drop the boxes on the customer premises and they extend the network into the customer premises. So the mobile core still runs on an operator edge, of course, but you do have a core running on the private edge. The control plane is in the public cloud or in the operator edge, and you have a user plane running in the private edge itself. If you have a core such as a firmed APC, for example, which is now part of the Azure family, it has a CUPS architecture. So you can do the separation, the control plane and the user plane on premises. And then many solutions, many scenarios are possible. Different slicing, depending on the scenario you have in mind, roaming or movement of devices, of cars, trucks between the locations can then handle seamlessly between the local location and the operator network itself as well. So these two scenarios, by the way, guys, they're actually happening as we speak. And the trick really, again, combine networking with computation, make it easy to manage from the cloud, and make sure it fits in with the operator carrier networks, because all these things have to get to market in the current environment we all have today. Lastly, I've been talking a lot about the edge. I want to tell you there's also movement happening in the journey of the core network itself. In this example, these examples are showing how some of the core network functions that today run on premises are frankly being disaggregated. Not just moving to virtualization and containers, which we all know they're happening anyway, but some are moving closer to the edge, like most of what I said earlier, and some are moving up to the cloud. So the control plane, many control functions are moving to the cloud slowly, but they're actually happening. Many other user plane functions, which are more latency sensitive, are being pushed even the other direction, closer to the edge as well. We believe it's going to be a journey. It's going to happen. It's happening as we speak. Some of the stuff is not happening in the core networks yet, but they are happening in IoT networks. They are very much happening for machine-machine solutions. And slowly but surely, I believe we will be able to combine the power of the public cloud, on-prem computation, and edge compute in the customer premises as well. Okay, guys, I know this was quick, and I do speak quickly. Be happy to take some questions. We have some time, but this is basically the core of my presentation today. Thank you very much.
Yousef, thank you very much. I appreciate you being here. And I have some questions, and I see some more coming in. I encourage you out there to use that Q&A button at the bottom. So, I think maybe I see some things that I would bundle together in the space of integration, or questions in the notion. You are kind of articulating a strategy of lots of different pieces, components, and players. And so, integrating all these pieces, of course, is then the next challenge, or the immediate challenge, of course. So maybe a way to think of it is, you talked about a couple of examples like Atobatix and others. Like, who did the integration in this case? Were there system integrators involved? Who was the prime? Was Microsoft playing a prime role in all of these? And then where do you see that market, evolving, or where's it going to land?
That's a good question, actually. I'll tell you, our approach is very much to lead with software. So there's typically an integrator, or more likely an operator, involved. But we are not, in our case, shipping a bunch of Lego blocks and leaving it as an exercise to the reader. If anything, what I didn't go through the details, orchestration and managing the components are a core part of the product. So the management layers are, frankly, the real key value we're adding in here. We do have first-party NFVs. As you probably know, we have the Affirmed stacks, we have the Metaswitch stacks available as options. And there are also marketplace options of other partners, Nokia and others. But the main value we're adding, to be honest, is a way to orchestrate and manage the whole thing, both the NFVs themselves, as well as, importantly, connecting back to the public cloud. So then you can gain the ability to do all sorts of things like monitoring, logging, understanding the data, and so forth. So yes, there might be an SI or a managed service provider to help you manage the infrastructure, but the integration is really done in the software and the product itself. Otherwise, frankly, anybody can buy a bunch of boxes from somewhere and try to do it themselves, but that's not really how we do business. It has to be, the value has to be in software.
And maybe, so then, I don't know if this is an extension of the same question, but sort of the operator edge, I could see that where it's the public cloud or the edge zones or on-prem, the relationship is easier. There are fewer players, but as soon as you add the operator edge zone, I think you called it, or edge zone with carrier, I think you called it, an operator is got to be in the mix. So how does an enterprise go about consuming an operator edge zone? I mean, do they go to the operator? Do they go to Microsoft?
The beauty of it is, if you're familiar how you use the cloud, you basically go to a web portal and you decide here there are locations you want to go and place your data or your computation and so forth. All these zones I mentioned earlier, be they the public cloud in a given location or an edge zone with a carrier or a net or on premises even, appear as basically as your local regions, as a location. So the same tooling, the same modeling you do to manage any computation can be applied there as well. The ones with carriers in particular, these are jointly deployed basically with the carriers, okay? But otherwise, the software, the model, and the like, it's a drop-down menu, and you say, this is my location, I put it there, and you go from there as well. The pricing and the like differs depending on the location, etc. But otherwise, it's the same model, same computational model, same management model.
All right. And a related question is from somebody is, are all Azure platform functionalities available at the edge, or are we still dependent on the central cloud infrastructure? And is there still, is it only a subset at the edge?
It's physics, guys. Of course, not everything's available on the edge. So if you want to store a petabyte of data, you're not going to do it on a 1U box. Let's be honest about this. Not today, at least. So no. So there is extensive set of services that are available all the way from the public cloud to the edge. They include the IoT stack, machine learning, AI, and so forth. But even for something like a machine learning model, you can only put so much on a 1U or a 2U box or a 4U box, whatever the case may be. So the subset of services available all the way to the edge, and the scale is smaller at the edge. Of course, in return, what you get from the edge, as you know, is really low latency. You are right there. The machine is right there. The device you're controlling is right there. So it's basically a balance of what should be closer to the device for latency purposes or data sovereignty, whatever the case may be, versus what you get in terms of high scale and high set of extensive set of services you have in a public cloud. But you'll be surprised how many of these services are becoming container-based and available anywhere on the spectrum.
And you didn't mention some of your other services like Azure IoT, for instance, or ML tooling and the like. So to what extent is that these additional services and these higher level services being integrated with your edge strategy?
They're part and parcel of the whole technology. So whenever I said computation, I do not mean a vanilla container by itself or a VM by itself. I meant really all these services you mentioned earlier. IoT, Edge, ML, AI, analytics, a bunch of these services that if they are run in a container somewhere, they can run all the way to the edge. So that business slide I showed had all these names in there, and many of those are available on the edge today. Again, deployed and managed the same way you would do it from the public cloud.
Mm-hmm. So I think you mentioned some of the notable public moves that Microsoft's made in the mobile core space. So I guess there are a couple of questions that are coming in here. So you're balancing. It seems like partnering with multiple core options with also the Microsoft options. So how do you differentiate and balance those in the market?
With our acquisitions of Affirmed and Metaswitch, think of them as our house brands. Our main goal is to make the cloud better to meet the operator core network needs. And what a better way to do it than to have the technology in-house to actually go and improve the cloud to meet all the needs of this infrastructure. So it's one thing to say, yeah, I have a cloud and I can run a packet core very well because I work with a partner X, Y, and Z. It's another thing when we have literally hundreds of engineers who know this stuff, know it more than the rest of us, who are mostly enterprise people, to be quite frank, and to make us all better. So think of them as our house brands. We work very well with database vendors, be they the third-party vendors or our in-house database vendors. Same with virtually every other piece of technology there are. So it's the same thing, really. And if you think about it, I'm an OS guy, by the way, at heart. The way you make an operating system better, you need somebody to drive you to make it better. You need an application to drive it better. Desktop OSs typically become better because you have an application like maybe the Office suite, for example. Or a server OS becomes better because you have a database that makes you better to make it really meet their needs. Mm-hmm. For us, the technologies we have in-house of Affirmed and Metaswitch will make the cloud better for everybody.
So thank you. So I see then another kind of group of questions. They're all coming, I would say, in the sort of the challenges at the edge. What are the challenges in edge deployment? Lights out deployments, physical, environmental constraints, temperature, and the like. So, and what have you learned, and what can you share with us?
On one hand, what I said earlier about the need to have software to manage quite a bit is extremely important. Okay. So you cannot have an army of people sitting in a NOC somewhere managing all these edge locations by hand. It doesn't work this way. So we don't manage the cloud this way. It's mostly software. So investment in software management, orchestration, I know the word orchestration is overloaded here, but manageability, monitoring, etc., is very important. At the same time, you have to have the right architecture here. So the ability to handle disconnected operation is a given. Because frankly, the factory floor has to operate, whether or not it's connected to the cloud at a given point of time. So disconnected operation is very important. Having said all that, the folks who are asking the question really understand another issue, which is on-premises. Also, bad things can happen. Somebody can trip over the antenna or the wires and the like. So you still need to understand that in a physical sense, you need somebody on premises. So the question earlier about is there an integrator in the picture and the like, there are typically some folks involved who can do the RMA, fix the hardware and the like on premises. And that's why we don't believe this is going to be purely a software play or a cloud play. It has to be a partnership with the operator who owns the spectrum, radios, and the customer relationship, as well as people on premises who understand how to handle with local customer premises equipment here. So it has to be a partnership. But again, the physical world is not the same as the virtual one. Bad things can happen.
Mm-hmm. And then maybe time for one more question. So there are a couple of questions that are a little more RAN focused, but I think I noticed you mentioning one RAN partner, but others are asking, Microsoft's made moves in the core. Does that pretend that that there's some things coming in the RAN space, or more about the RAN strategy and private LTE strategy for Microsoft?
We are very much partnering with virtually the whole ecosystem, from the big NAPs to the smaller, CBRS and vRAN partners here. So you're going to see us partnering very closely and integrating the RAN solutions, be they vRAN or otherwise, with the cores we have and with the public cloud here. So again, our objective here is to meet the customers where they are today. And please note, we're also a global company. So we have to meet the needs for virtually every market out there. So CBRS is great in the US, but we must work with operators around the globe and meet them where they are. So it's all about partnerships when it comes to RAN.
Mm-hmm. Okay. Well, good. Well, I really appreciate you joining us today. I think that, what you're sharing is right on point with this event, and we just see so much activity and interest in this space from multiple perspectives. So, thank you again.
Thank you very much.
So, with that.